Okay, now we are going to introduce the DHCP Snooping configuration. And firstly, let's see the background. To simplify the OM, a company has enabled the DHCP function on the core switch in its network, allows for automatic address assignment to the numerous terminal devices within the network. Customer found an issue where employees were connecting their home wireless routers to workplace. In this way, they can increase the access points. However, since the automatic address assignment function on the home routers, terminal devices in the network will frequently receive incorrect IP addresses, resulting in abnormal internet access. So to prevent these things take effect again, we need to enable DHCP snooping feature to address this issue. And the purpose of this lab is to help you master the application scenario of DHCP snooping and master the principal configuration commands, status check commands of the DHCP snooping. The topology is shown here, and you can also see I have created a topology on the and as you can see, I have already created the topology, which is the same as what you can see in the lab guides. And then is a requirement. SW1 is a network's core switch with DHCP enabled, allowing for automatic IP address assignment to network terminals. This experiment uses routers for simulating, and the interface often is addressed through DHCP. So R1 is, you can think is the home wireless router. R1 you can think is just an PC, and we use the G00 ports on R2 to get the DHCP address. Okay, SW2 is an access switch which provides access service for LAN users. Wireless router is a home wireless router for LAN users. It assigns an incorrect IP address, which subnet is shown here, 10.1.1.0/24 to the users. And the LAN user address segment is 192.168.1.0, mask length 24, and the gateway is 1.254. And we should enable the DHCP snooping function on the access switch, which is SW2. Right, in this figure. And to do the lab, firstly, we should finish the configuration of the DHCP. Right, so we call it the basic configurations. And now let's do it together. Firstly, is on SW1. Here we can change the name to be SW1. And on SW1, we create firstly create VLAN 10, and then set the IP address of SVI 10, which is okay. And then next is about the configuration of the ports. On SW1, actually, we only have one port, which is G00. So interface G00, switch port mode trunk. Switch port trunk allow VLAN only 10. Okay, here we set the limitation. This trunk port only allows VLAN 10. And we should enable the DHCP service on SW1. So service DHCP. And the next is the configuration of the DHCP port, IP DHCP port. The name is Ruijie, and this network. This is a subnet, and the gateway is the IP address of SVI 10, and the DNS server is And last is the lease. Okay, this is optional, right? You can just use the default lease. Okay, so until now we have finished the configuration on SW1. The next is SW2. First, they change the name to be SW2. Okay, and then first create VLAN 10. And in VLAN 10, we should add interface G00. Sorry, add interface G00. Add interface G02. Okay. And the next for the interface G01 is connecting with the SW1. So interface G01, switch port mode trunk. Switch port trunk allow VLAN only 10. Right? Okay, this is about the configuration on SW2. And next, since we should simulate that on the wireless router, it can also assign IP address. So we should also enable the DHCP service on the router R1. So let's do it. Interface G00. IP address 10.101.1. Mask length is 24. And we should enable DHCP service. So service DHCP and create a DHCP port. Here we name it as illegal. And the subnet is 10.1.1.0, mask length 24, and the gateway 192.168.1.254, and the DNS server. Okay, and the last is this. Okay, after finishing this, next is about the configuration of the R2. And since here R2, you can think R2 is a PC, so we can also change the name, host name PC, right? And for the PC, we use its interface G00, IP address DHCP. So the physical port G00 on the PC on R2 can automatically get IP address. And as you can see, now its IP address here is 192.168.101, right? And this is the correct IP address, right? But let's have a try. If we can get an wrong IP from the illegal DHCP server, we can delete the IP address of this port and get another one. Here, wait a moment. Okay, now you can see it gets an IP address which is 10.1.1.2. Actually, this is the wrong IP address. And after getting this IP, we cannot access the network anymore. Okay, so here we can see this problem and how to solve this problem. Let's see. We should complete the DHCP Snooping configuration on SW2. So let's go to SW2. This is SW2, and to enable the IP, to enable the DHCP Snooping, the command is IP DHCP Snooping. And since we have enabled DHCP Snooping, so we should set the port which is connected with the DHCP server to be the trust port. Here is interface G01 IP DHCP Snooping trust. Okay, and after enabling DHCP Snooping, we should verify the results. Now, let's confirm it first. IP address we have is 10.1.1.2. It's a wrong IP address, so we can use a command no IP address to delete it, and IP address DHCP to get a new one. It takes a moment. Okay, now you can see the IP address we get is 192.168.1.1, or we can maybe have a try. We can delete it again. No IP address, and the IP address DHCP to get a new IP address. Now you can see it's still 1.1. So after enabling DHCP snooping, we will not get the wrong IP address from the illegal DHCP server, right? And then next, let's go. Config SW2's 00 interface connect to the wireless router as a DHCP snooping trust interface. Leave all other ports in the default untrust state. This will ensure that PC always receive the address from the wrong DHCP server and get the wrong IP address. Let's try again. Let's go back to SW2. Firstly, we should delete the configuration here. You can see we have set these ports to be the trust ports. Now we should delete the no IP DHCP snooping trust to delete this command. And after deleting this command, this port G01 is the untrust port. And for interface G00, let's see, IP DHCP snooping trust. And go to the PC. Let's see, delete the IP address and get a new one. Okay, you can see you get an IP address 10.1.1.2. This is the wrong IP address because we have set the interface which is connected with the illegal DHCP server to be trust. So the PCs can only get the wrong IP address. Okay, and the next step, to ensure that only authorized DHCP server provide IP addresses and that those unauthorized servers are blocked, necessary to configure the interface connect to the DHCP server as trust, right? By using the command we just introduced. And in this case, we can use the command show IP DHCP snooping command to check the DHCP snooping status. You can see show DHCP IP DHCP snooping. You can see the DHCP snooping is enabled, and now G00 is the trust, is trusted. Actually, it's wrong. So here maybe we can modify it. Interface G01 IP DHCP snooping. Okay, and check again. You can see now interface G01, which is connected with the DHCP server, is the trust interface, right? And at the same time, we can check the DHCP snooping binding table. You can see the PC is binding with the wrong IP address. Actually, the reason is that the IP address of the PC now is still the wrong IP. You can check it. It's still using 10.1.1.2, so we can delete and get a new address. here it takes a moment, so let's wait a moment. Okay, now you can see got an IP 192.168.1.1. This is the correct IP, and if we check the mapping again, show IP DHCP Snooping binding, you can see the PC is mapping with the IP address 192.168.1.1. The lease still have about 10 hours, right? And the VLAN is VLAN 10. The interface is G02. Okay, so this is about the configuration of IP DHCP snooping. Okay, that's all for this part.